We have the last speaker, Haitham Ezzy, integrating deep learning and multiscale ecosystem connectivity of the marine habitat.
Hello, everybody. Exactly the last 10 minutes before lunch. It's perfect.
And you only have...
Yeah, and the reviewers said that it's too ambitious, with my work, so let's see.
You see it?
Easy, yeah. It's this one. Thank you for this opportunity. My name is Haitham Ezzy. I'm from the lab of remote sensing, Haifa University. I'm a PhD student. And this work, I collaborated with my professors, Brook and Dror. Okay, we here gathered together talking about the marine ecosystem and the importance of it. So just not to remember always that they are under threat from human activities like overfishing, pollution, and climate change. What I believe that what's missing in this field is the linking between the fish and their habitats. People talk about it only on 2 dimensions, not in 3 dimensions. So this work focus on linking between the fish and their habitats by helping with the AI and machine learning and the 3D models to understand the complex marine ecosystem by analyzing large data sets and uncovering patterns for better conservation. And the 3D modeling offers precise mapping of underwater structures, correcting the limitation of the 2 dimensions models. Our objectives include evaluation the current state of marine biodiversity using AI and 3D modeling, advancing seascape characterization methods, developing predictive models for conservation, and optimizing monitoring and management of the marine ecosystems. This is our flow chart. So I'm going to talk about the data acquisitions. We have 5 data sources, divided 2 parts. The first one is about the bathymetry, the second one about the fish and the biodiversity, then pre-processing using machine learning and the main model and our results. The case, it's in this research area in the Haifa coast, up to 30 meters depth, and includes specific marine protected areas like Rosh Hanikra and Akhziv. Data acquisition. So we combine data from airborne LiDAR scans, underwater videos, archived multi-beam echo sounders, and high-resolution 3D modeling from photogrammetry. Start with the LiDAR bathymetry. We use LiDAR sensor mounted on aircraft to capture the high-resolution bathymetry data. This involves pre-processing and classifying point clouds to remove all the noises and these things, to create the digital elevation model, or can call it DTM. We reach a resolution of 0.5 meters, 50 centimeters, and it's very high resolution. We believe that we can reach up to 12 meters, but after the first survey, we got to 30 meters. To validate our data LiDAR acquisition, so we dived and look if what we see in the DTMs, this is what we have in the seabed. We can see in this point, this is the channel, and this is it in the still cameras. I took it by GoPro. Move to the multi-beam echo sounder bathymetry. It's archived from the 90s and have a very large coverage over the seas, especially in the Israeli coast. We can see the difference between the resolution. See, the green one is the LiDAR, the blue one is the multi-beam echo sounder. The resolution of the multi-beam is 5 meters per pixel. See the difference, like 50 centimeters to 5 meters. We're losing a lot of data till now. The third data acquisition is the 3D models from photogrammetry. Photogrammetry validates the LiDAR data in areas where there are missing information, like caves or cracks or underneath rocks. So we support it with the 3D models from photogrammetry, which are processed into detailed 3D models, ensure accurate and complete marine habitats. Okay. Talking now about the bathymetry. So the pre-processing step is using super resolution GAN, if somebody familiar with it. It's a type of machine learning model using enhancing image resolution. So I take this model and work with it on maps. And I got these results. In the left side, we have the multi-beam and the LiDAR. They were the data set. And on the right side, the enhanced, this is the output of our model. We can see that we improved between this one and this one. We improved for the multi-beam and the enhanced almost 80–90%. And this is an amazing result. Moving to the part of the biodiversity and the fish data set, we use 360 degrees cameras to monitor marine biodiversity. These cameras provide comprehensive data collection, offering advantages over the traditional methods. Like before, they dived, take tablets, and count fish and write what they see. Now what I'm doing, I'm fix cameras, 360 degrees, and come back after 2 hours, take this camera, and do it all over the year and different seasons. We need to support this data set. So we took BioBlitz from the authorities. This archived over several years to validate our fishing data set, focusing in a group of fish that can tell us the status of the habitat itself. Like if it's healthy habitat or not, it's with high biodiversity or not. We're talking about a group of predators, only 5 species. Also, I can't cover all of the species. In this slide, we can see the sampling point of the cameras and the BioBlitz. Here, the sampling point on the DTMs from the LiDAR and the enhanced bathymetry. Now moving the pre-processing of the biodiversity. First, we need to detect and classify the fish. So we used YOLO. It was version 7, and now we're using also version 9 to detect its deep learning algorithm. And this is the result of the training. The precision, we got 80%, and we are ongoing. We had to support our data set also from other sources of images, because what we got is not enough. Here we can see in the left side video. There are small fish. Almost we can't see it with our eyes. Our model can do it almost perfectly. Here's another one with big fish. It's moving, that one? No? Okay, never mind. Okay, so now the main model. We combine multiscale geomorphometric feature to analyze habitats at different scales, enhancing our understanding of habitat complexity and connectivity. This approach integrates physical elements, scale, largest scale vertical relief, and the small scale complexity to provide comprehensive view of maritime habitats. Like these are different type of features. Now, I repeat again, the main goal is to bridge between the structural connectivity, that means the bathymetry, and functional connectivity, it's the biodiversity and the fish. So our approach is like that. Using machine learning, classifier like XGBR or convolutional neural network, we try in both of them because we don't know how it should be working. So the input is structural connectivity and functional connectivity data to the classifier. When training the model for low, mid, and large scales, we trained in three times separately, in the low scale, mid scale, and high scale. Then we combine them into a multiscale model. The process is ongoing, and we have primary results. This is one of them. It's a special map with habitat suitability scores, low, medium, high, and very high. In the middle, do you see my cursor? No. Yeah? Okay, so in the middle is the big area. It's sand, so less diversity. And when we see red lines, it's where it's more complex reefs. And it's saying that it's higher diversity. Going to the conclusion. In conclusion, our work includes enhancing seafloor mapping with super resolution GAN, improving the LiDAR and the multi-beam resolution. We use machine learning, 3D modeling for biodiversity assessment, analyzing species distribution for monitoring. We employ 360 degrees cameras and YOLO V9. Data validation is ensured through photogrammetry. We see calibration for fish data and test areas for further advance our research. And that's it. Thank you.
I can allow for one question. Uta, come and meet me. Fast.
It is almost not a question to Haitham. Thank you, Haitham. Very nice presentation. But to dig, if that is a possibility for eModNet to take this data in such high resolution that he has collected.
No. No, I think, let's say, it's a brilliant presentation. I like very much how you use all these new technologies to say, and bring them together and integrate them. And it's because, like I say, multidisciplinary approaches are more and more needed, and you are trying to connect, let's say, different worlds.
This is remote sensing. This is what we do.
Yeah, but it's very good, and that's why also with the bathymetry, of course, you have very local bathymetry, LiDAR, and the LiDAR, of course, can fit in AMONET bathymetry excellently, no problem. If you have some good metadata, but you will have, I'm
yes,
pretty sure. And but also what you do with super resolution, like I presented also in AMONET bathymetry talk, I said also we are looking into super resolution because it's a way to get more out of the pictures, say the satellite images, but could also be, of course, LiDAR and others. And also the multi-beam can be improved then, that you can go in painting, let's say. And,
yeah, like we took the multi-beam echo sounder coverage, that is coverage much more area. The satellites can reach, I think, less depth or less precise. So, sorry. So we can, I think, to train a model, it's that easy. To have the data, this is the problem. It's cost money and.
yeah, of course.
Yeah. Yeah, thank you. Yeah, thanks.
Thank you.
I see no other questions, so that's it. So thank you very much all presenters for their very interesting work and for presenting us their latest progress.